Hello, algebraists! So in this video, we are going to talk about graphing linear equations. Linear equations. So let's talk about what a linear equation is, and then we'll do some graphs. All right. So before we do that, let me point out before we do that graph you just saw, we're going to talk about what a linear equation is. All right. So a linear equation. What does that mean? Well, that means that you can write the equation in this form. ax plus by equals c for some numbers a, b, and c, where a and b are not both 0, right? These are numbers. They can be integers, they can be fractions, they can be irrational numbers like pi, whatever, but they can't both be 0. Okay, so not both 0. So if you can put the equation into that form, then it's linear. So some examples of linear equations might be, let me peek and look at what we're going to be looking at. 2x minus 3y equals 4. That's an example of a linear equation where a is 2, right? B is, we're adding by. What do you add to get negative 3y? Well, your b would have to be negative 3. And c is 4 in that case. I can find numbers a, b, and c to get this to be this, and therefore this is a linear equation. Okay. Another one would be something like x equals 1/3 y plus 8. Now that one you might say, well, wait a minute, that doesn't look quite like this. I've got the x on the wrong side of the equal sign, but that's okay. We can use algebra to get this to look like that, right? If I subtract 1/3 y from both sides, I get this equation. And so this, through a little bit of algebraic manipulation, this thing becomes this thing. And now I can see that this is a linear equation with a equals 1, b equals negative 1/3, and c equals 8, right? This is of this form. So with a little bit of algebra, you can see that this is actually a linear equation. Okay, let's do another one. Let's do y. Let's do plus 7 equals 0. Is that a linear equation? Well, let's see. We need to be able to write it like this. Right, so can I put it into that form? Well, the 7 has got to end up on the right-hand side. That's going to be our c, right? So let's subtract 7 from both sides, right? So I get y equals negative 7. Now, is this one of these? Well, there's no x, but that's okay. If I let a be 0, then that would make the term with the x in it go away, right? So this is the same as 0x plus 1y equals negative 7. Right? So in fact, this being the same as this, I now see that a is 0, b is 1, and c is negative 7. So this is, in fact, one of these. So it is linear. Okay? Well, what about this guy? Let's try another one. X squared plus y squared equals 9. Can I get this into this form? Well, the answer is no. There's no way to get rid of these squares so that this gets into that form. And please do not try to do this, square root. You could take the square root of both sides. That's a valid thing to do. But this is not the same as not equal to x plus y. So that's not the same as x plus y equals 3. You can't distribute a square root across squares. So that I can see why that might be a tempting thing to try, but that doesn't work. You can't simplify it beyond this. Right? Another thing, so this is not linear. This is the first example that we've had of a nonlinear equation. What about, let's see, let's try square root of x minus y equals 4, something like this. Well, this one, the problem is I have a square root on the x. How would I get rid of that? Well, you might try squaring both sides to get rid of it. Let's try that. But when I do that, now I've got to, now keep in mind, I've got to, some of you know the FOIL rule. If that's the one you know, then that's what you can do. Or you could write it like this. If you square something, it's the same as multiplying it by itself, and 4 squared is 16. And when I multiply this out, I get root x times root x is x. Oh, that's good. But then I get root x times negative y, so I get a negative root xy. And then I get another root x times y. And then I get minus y times minus y. Well, this is hopeless. There's no way I'm going to get rid of these square roots and these squares. There's no way I can get this into a linear form. This is not linear. So it's only linear if you can use algebra to get it into this form and identify what the a, b, and c are. That makes it linear. Otherwise, it's not linear. Now, the nice thing about linear equations is they all have particularly nice graphs. So let's take a look at some of these graphs and see what we're getting here. Okay, so in our first example, we have this guy. Okay, so let's see what we can do to graph this. Okay, so what I would do, just like in the last video, is make a table. Right? So let's make a table of values. I got values for x and values for y, and these will give us points that we can then plot over here. Okay, so let's first try -1 for x. And then we'll try some other values here. We'll try 2, we'll try 3. Okay, and let's see what we get. So if I let x be -1, what would the y end up being? Well, let's see. I'm going to have 2 times -1 minus 3y equals 4. Well, this is -2 minus 3y equals 4. Right? That's -2 minus 3y equals 4. Now, I'm solving for y here, so let's add 2 to both sides. So now I have -3y equals 6. So I'm solving for y, so I'll divide both sides by -3. And I get y equals -2. And there's my answer. This is -2. So by substituting this number in place of x, I can then solve for y and find out what the y is. Okay, so you do this one. Okay, and I'll pause. Let's pause the video, get out a piece of paper, and work this one out. Find out what the y is corresponding to x equals 2, and then we'll meet again and we'll check our work. Okay, so I'll count to 3. 3, 2, 1. Okay, welcome back. Let's see what you did here. So you're taking x to be 2. So you're going to take 2 times 2 minus 3y equals 4. And then you say, well, okay, well, 2 times 2 is 4. I'll subtract 4 from both sides. I get -3y equals 0. Divide both sides by -3. 0 divided by -3 is 0. So y equals 0. You should have gotten this. Okay, now let's try 3. 3 for x. Okay, I'm going to have to go over here, all right? I'm running out of room over there. So when x is 3, what happens? Well, I'm going to plug 3 in place of x. Go ahead and work this one out. Now, these we got integer answers. Don't be surprised if you might get something a little bit different here, okay? So pause the video, work it out, see what you get. All right, so 3, 2, 1. Okay, welcome back. We're going to plug the 3 in place of the x. So I'm going to have 2 times 3 minus 3y equals 4. All right, so this is 6 minus 3y equals 4. And subtract the 6 from both sides. Divide both sides by -3. and we get y equals, well, the negatives they cancel, they become a positive. So what I'm getting here is, let me squeeze it down here so I have room to write the next one. Okay, y equals 2/3. So my answer here is 2/3. So it's a rational number. It's not an integer, unfortunately. So let's try one more value. We've been picking numbers for x and finding y. Do we have to pick numbers for x and find y, or can we choose numbers for y first? We could totally find numbers for y first. So let's see, I had one ready here. I think 2 would be a good idea. So what we're going to do is we're going to look at y equals 2 and see what that gives us. So in place of y, I'm going to put a 2. Right? So I have 2x minus 3 times 2 equals 4. 2x minus 3 times 2 equals 4. Okay, so that's 2x minus 6 equals 4. I'll add 6 to both sides. 2x equals 10. Divide both sides by 2. X equals 5. So from the y, starting at 2, we noted that the x ended up being 5. So we got a table of values, so we can plot these. Right? So let me get out of our way here. And let's plot the first one. X is -1, so I go -1. And then y is -2, so I go -2 right there. So that's my first point. 2, 0. X is 2, 1, 2. Y is 0, so I don't go up at all. I just stay right where I am. So that's my second point. Let me skip the fraction one. All right, we'll come back to that one. Let's do 5, 2. So x is 5, 1, 2, 3, 4, 5, and y is 2, 1, 2. So we're right here. That's actually enough to draw the line. Okay, but let's go look at this one. This is 3 2/3. All right, this is going to be tricky because my grid is so small. So it might be best just to not do the fractions, but I want to point out how you do it just to be clear. So we'd go x is 3, 1, 2, 3, and then y is 2/3. Now 2/3, what I'm going to do is I'm going to split this into thirds. See, 1, 2, 3, right? So 2/3 is 2 of those thirds. So 1, 2. So it'd actually be right there. Okay, so just split it. If it was fifths, you'd have to split it into 5 parts. It would be almost impossible on a grid this small, right? I think thirds are as tiny as I'm willing to go here. Now let me get a straight edge. I'll use my phone, and we'll sketch this line. Okay, so draw a line through those dots. Okay. And that line continues in both directions indefinitely. That's what we're getting here. And now we see why we call these linear equations, right? The graph is a line. Okay, let's go down and take a look at this next one. Let's move the camera this time. Okay, so we have 5x plus 2y equals 6. We're going to do the same thing, all right? So let me get out of the way. And we are going to make a table. So x and y. So let's pick some numbers for x and y here. Let's pick -2 and -1 for x. And then I'm going to, just for fun, choose a value for y, just to point out we can do it both ways. Okay? So let's start with x equals -2. All right, so you're going to plug in -2 for x and solve for y. All right, so pause the video, work it out, and we'll check our work together. Okay? So 3, 2, 1. Okay, welcome back. Let's check our work. So x is -2. Okay, so in place of x, I'm putting a -2. That's -10 plus 2y equals 6. Add 10 to both sides. 2y equals 16. Divide both sides by 2. Y equals 8. So there we go, 8. -2, 8. Let's go ahead and plot that point here. -2, 1, 2, 3, 4, 5, 6, 7, 8, right here. Let's do the next one. X is -1, y is what? Right? So go ahead and work this out, and we'll check our work together. Okay? 3, 2, 1. Welcome back. Let's see what we got. So you're plugging in -1 for x. So that's -5 plus 2y equals 6. Add 5 to both sides. 2y equals 11. Divide both sides by 2. And what do we get here? We get y equals 11 halves. Okay, that's my answer. Okay, let's do the one for y equals -7. Okay, let's do that one. So y equals -7. Okay, work that one out, and I'll meet you back here. All right, so pause the video and work it out. See what you get for x. I think you should get a nice integer number for this one. Okay, so 3, 2, 1. Okay, let's come back. Welcome back. So 5x plus 2 times -7 equals 6. All right? Okay, so 5x minus 14 equals 6. So add 14 to both sides. 5x equals 20. Divide both sides by 5. We get just out of room on these. So x equals 4. X equals 4. So that's what goes here. Okay. We got this point we can plot. 4, -7. 1, 2, 3, 4, -7. 1, 2, 3, 4, 5, 6, 7. Right there. Now what about this -1 11 halves? Let me show you how you could plot that, okay? You might just try a different number so you don't get a fraction. That I would recommend doing that. But if you, in a pinch, if you did want to plot the fraction, let's go through this. So x is -1, so we're going to be over here, right? But then we have to go up 11 halves. So let me break these into halves. There's a half, 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 half. Okay, we're going to count 11 halves. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there. That was 11 halves. So I broke the intervals into halves, right? And then I just counted 11 of them, and that's 11 halves, right? So we can make our line through here. Now you might be saying, Professor, why are we plotting 3 points? Aren't 2 points enough to draw a line? And you're right. We don't need 3 points to draw a line, right? You can actually get away with just 2. You do need at least 2. But why am I keep plotting 3? Why do I keep plotting 3 points? Well, there's a good reason. If I plotted just 2 and drew the line through there, that's great if I didn't make a mistake. But by plotting the third point, it's a way of checking my work, right? If I plot an additional point and it also lies on the line, that makes me think that, oh wow, I didn't make any mistakes, right? So by plotting 3 points, we're just it's a way of checking to make sure we didn't make any mistakes. If you just plot 2, you're being very risky, because if you made a mistake, you'll never notice, right? Okay, let's take a look at some other ones here. Let's look at this guy. Y equals 1/3 x minus 2. Okay, let's see what values we could choose here. Now on this one, notice that it's already solved for y. It's already solved for y, so it makes sense to just choose numbers for x, right? Because you'll see how easy it is to get y once we choose some numbers for x. So let's take x to be 0, we'll take x to be 3, and let's get a negative number in here. We'll try -6. Now I'm being very careful how I choose these. Notice I have a 1/3 x. So it makes sense to choose numbers that are divisible by 3. If I choose a number that's not divisible by 3, I'm going to get a fraction. Let's avoid that by choosing numbers that are multiples of 3. And that way we won't get any fractions, right? So good, we were careful about that. Let's go ahead and compute these. So when x is 0, y equals 1/3 times 0 minus 2. Well, 1/3 times 0 is just 0. Subtract 2 is negative 2. Well, that was easy, right? See how easy it is when it's already solved for y? It's y equals. Super easy, right? Let's try x equals 3. You go ahead and do this one, and we'll check our work together, okay? So pause the video and work it out. 3, 2, 1. Okay, welcome back. Let's see what you got here. Y equals 1/3 times 3 minus 2. Well, 1/3 times 3, 1/3 of 3 is just 1. 1 minus 2 is negative 1. Cool. All right, and this one, go ahead and pause the video, work it out. 3, 2, 1. Welcome back. Let's see what we got. It's 1/3 times negative 6 minus 2. What's 1/3 of negative 6? Well, 6 divided by 3 is 2, but there's a negative here, so it's negative 2. Negative 2 minus 2 is negative 4. Okay. Another way to work that out is to say that, well, 1/3 times 6 is 1/3 times 6 over 1. Multiply the numerators and denominators. Do not cross multiply. That's not appropriate here. All right. You just multiply straight across when you multiply fractions. 6 divided by 3, and that's 2. And then note there was a negative, right? So you actually get it. This becomes a negative 2. And then you subtract 2, you get negative 4. Okay. All right. So let's plot these. 0, negative 2. All right. 0, negative 2. 3, negative 1. 1, 2, 3, negative 1. Negative 6, negative 4. 1, 2, 3, 4, 5, 6. Negative 4. 1, 2, 3, 4. Right there. And we draw the line. There we go. Great. Okay, let's go to the next one. X equals 2y plus 5. Okay. So I'm going to make my table. Now, what should we put in this table? Well, notice it's solved for x. So it makes sense to choose numbers for y. All right? Because it's already solved for x, so it'll be very easy to get the x values once we pick y values. So let's do negative 3, 0, and 1. Okay? So go ahead and work these out, and we'll come back and check our work together. You can do all 3 of these. Okay? So pause the video. 3, 2, 1. Welcome back. Let's work these out. So the first one is going to be x equals 2 times negative 3 plus 5. All right, I'm just plugging a negative 3 in for y. So that's 2 times negative 3 is negative 6 plus 5 is negative 1. What about 0? X is equal to 2 times 0 plus 5. 2 times 0 is 0. 0 plus 5 is 5. The next one, x is equal to 2 times 1 plus 5. 2 times 1 is 2, plus 5, 7. Cool. All right, so now we can plot these. Go ahead and plot these. Let's check our work together. All right, so pause the video. 3, 2, 1. All right, so here we go. Negative 1, negative 3. 5, 0. And 7, 1. Right there. Notice they all ended up in a straight line. That's a good check to make sure we did it right. If they didn't lie in a straight line, we know we did something wrong because this is a linear equation. All right, great. I have just one more. We're going to do one more. Okay? Here we have the equation x equals 3. Is that a linear equation? Well, yeah, because I can write this as 1x plus 0y equals 3. So a is 1, b is 0, c is 3. It's a linear equation. So we should be able to plot this just like we did the other ones. All right. Now, it's solved for x, so it makes sense to choose numbers for y. All right. So let's try y equals -2. We'll try y equals 0, and we'll try y equals 4. Let's try these numbers. Okay. So I'm going to plug everywhere I see a y. I'm going to plug in a -2. Okay. Okay. Everywhere I see a y, well, I don't see a y, so nowhere to plug it in. So I'll just write down what I've got. X equals 3. All right. Well, that's my x. Same thing for the 0. Everywhere I see a y, I'm going to put a 0. There are no y's, so it doesn't matter. I'm just going to write down what I can see up there. X equals 3. Well, x is 3. Same thing for this one. Everywhere I see a y, I'm going to put a 4. There are no y's, so it just stays x equals 3. I get 3. Okay, I got 3 points. Let's plot them. 3, -2. 1, 2, 3, down 2. 3, 0. 1, 2, 3, up 0. It's right there. And 3, 4. 1, 2, 3. 1, 2, 3, 4. Look at how easy that was, right? It's a little bit weird, that equation, right? Because there's no y's in it. But what that means is it doesn't matter what y is. Y can be anything as long as x is 3. So what we get is we get the collection of all points whose x-coordinate is 3, but whose y-coordinate can be anything. And that gives us a vertical line. Okay? Gives us a vertical line. Notice that if I tried to take x to be a different value here, like -1, what would that give me? Well, I plug that in for x. I get the equation -1 equals 3. That's not a true equation. That doesn't work, right? So there is no y that goes here. Does not exist. So I can't plot a point above -1. Nothing to go there because the y doesn't exist. I'm forced to only choose x's that are 3's here because that's what the equation dictates. Okay, so we have to just get this single vertical line. You should also figure, I'll let you figure this one out on your own. I'm not going to go through this, but here we have y equals a number. What's that going to be? I'll let you work that out. Make a table and plot it out. See what you get. Okay? So that's it for this video. Linear equations. So we talked about what a linear equation is, how to identify it. We talked about a few nonlinear equations, how to spot them. If you see a square or a square root, those are warning signs that probably aren't going to be able to write that as a linear equation. If you can use algebra to get it into that form, ax plus by equals c, linear equation. And that means the graph's going to be a line, and we can find that line just by plotting points. Okay? So that's it for this video, and I'll catch you on the next one.